Hey everybody, this is video C19. We are talking about combinations. Remember, combinations is where order doesn't matter. And look, some of them even have answers on them. Sorry, I get excited when I do that, nice, so I don't have to look up. Okay, how many combinations can be made from the word hexagon? Okay, so I wonder what it look. It says combination. Oh, here's a tip. You want to do your assignments in this section as soon as you get them. So that if the question or the assignment just says fundamental counting principle, that's all you use. I've seen a lot of students in the past, they'll get to the combination section and they'll go back and do stuff. And they're just using the same formula all the time. So you really want to stay on top of it. But this is a super easy one because it says combinations. And we're going to use the word hexagon. So combination. 1, 2, 3, 4, 5, 7 letters to choose from. That is my N. I'm going to take 3 letters at a time. Okay, I'm going to make it easy. 7, choose 3, 35, done. Okay, in case you don't have the magic calculator, I'll just do it for this first one. Our formula NCR is going to be n factorial n minus r factorial r factorial. That would be 7 factorial. Sorry about that. All right, so 7 factorial, 7 minus 3, brackets, factorial, factorial. 7 factorial, 7 minus 3 is 4 factorial. Remember I said these two numbers are always going to add up to that one. Let's see. 7 factorial, 5 by 4, factorial, 5 by 3, factorial, 35. Now, why would you do it this way if you can do it? You wouldn't. If you have a calculator on this question, this much on an assignment or something like that is fine. And there's my answer. This is if you don't have the right calculator and you don't have a combination button. So there you go. You know, I bet you could pause this video and probably do all the questions. Give it a shot and then come back. Let's see. A general manager of a fast food chain must select 6 of 15 restaurants for a special promotion. How many different ways can this selection be done? All right, so how many restaurants are there? There are 15, and he has to choose 6 of them for this promotion. Now, notice it doesn't say it's a different promotion in every store. So that's kind of a hint that it's going to be a combination, not to mention the fact that top of the page says combination. So 15, choose. Okay, make sure you're choosing 6. Oh, by the way, if you mess up and you go 6, choose 15. If you accidentally reverse your numbers, you know what? Your calculator is going to say, yeah, no, that's not how you do it. So don't get all worked up about remembering which one goes there, where, because if you put it in backwards, you're going to get error, math error or something. Okay. A random sample of 10 students is to be chosen to complete a questionnaire. How many different samples can be chosen? I'm pretty sure part of this question is missing. Let me just see what happens if we do 10. Yeah, no. 10, choose 10. 10. Oopsies, nope, nope. Back. 10, choose 10, should be 1. Oops. Okay. So I suspect when you actually see this question, it'll be fixed. So I want to know 10, choose 10, choose 10. 0, 0, 0. That's what the question is asking. I don't know how big my group is because obviously I didn't copy this question out right. So I'm going to be really lazy and just do a guess and check. I think I could figure it out mathematically, but I'm just more, let's just start 15. Choose 10. Oh no, 15 choose 10 is not nearly big enough. Okay, well, let's try 40. Choose 10. Oh, nope. That one way too big. So now I know my number is somewhere between 15 and 40. That overseems a little bit better. Now let's try 20. Choose 10. All right, so 20 choose 10 is 184,000. You're looking for 30 million. Oh, maybe I wasn't high enough. Okay. And I really am just guessing. 30. Choose 10. There we go. Okay. A random sample of 10 students out of 30. I'm going to highlight that so I will fix it when you see your copies. All right. How many different sets of numbers are there? So 649. Oh, I get excited when that's what I want when the jackpot gets big. I tend to buy tickets every once in a while. All right, so there are 49 numbers, and you get to choose 6. 49. 6. It's going to give me that 13 million. 9, 8, 2, 8, 1, which is exactly what it is. Okay. I might just take all the answers off your worksheet. Okay, well. Okay. How many ways can you pick all the, well, there's only one set of winning numbers. So that's why the answer is 1. Mathematically, you could do that there's 6 winning numbers. You have to choose all 6. And that's going to give you 1. In how many ways can you not match a single number for Lotto 649? Well, my first thought was we'll just take this, subtract 1, but that's not right. Because that means you didn't get all the winning numbers, but you got some of them. What we have to do is there are 49 numbers. I'm going to have to choose how many I'm going to have to choose. What do you think? I think my answer should be, now I'm overthinking it. I'm thinking it should be 43. But I'm not sure that's going to work. Let's try it. And 43 comes from, there's 6 right numbers. I need to choose from the wrong numbers. Choose 43. No. I'm gonna pause. Okay, so the moment I turned off the video, I knew exactly what the answer was. Okay, so here's the logic. Because what I wrote there was starting out with 49 numbers and picking 43 of them. That didn't make sense anyway. Because how many numbers do you pick? You know, that part is 6. Okay. But what we have to do is say, okay, so there are 49 numbers, and I can't get any of the 6 winning numbers. So I can't use, let's just imagine the answer. The winning numbers were 1, 2, 3, 4, 5, 6. Which means I have to choose from the remaining numbers. I can't have any of those winning ones. So if there are 49 to start with, and there's 6 that I can't pick because those are the winning ones, that should be 43. And there it is. I just did it. 43 to 6. I'm going to put that little note there of not winning numbers so that, you know, if somebody's looking at it, they'll know where that 43 comes from. Actually, I'm going to do this. 49 minus 6, 3. So this is my total numbers. These are my winning ones. And these are not winning. There. All right. How many combinations contain at least one winning? Oh, remember from set notation, or even earlier in this, you know, at least is a terrible word, but we are going to cheat. We're going to use the complement. So let's just draw my picture. You know, when I say complement, I'm going to do subsets. There are 13,983,116 different possible combinations of 6 numbers I can have. Now, out of that, we just figured out that 6,096,454 of new numbers on them. The person would be like super disappointed. Well, if these are the ones that have absolutely no winning numbers, then what we want is the number here in the complement. Remember that from set theory, right? Sometimes it's easier to find to subtract rather than doing it by cases. So that's going to be 13,983,816 minus 60,964. 54. And oh, I was going to say, and there's my answer, but I don't even have my answer on here. 13. Minus 60,964,5. 7, 8, 7, 3, 6, 2. There's going to be 7, almost 8 million tickets that have at least one number. Okay, so if you didn't remember this, what you'd be looking at is figuring out. Hold on. You know what? Let's do it. We can do this by cases. No, because that'll come later. I'm just gonna, I think I'll redo this question when we talk about combinations for more than one set, because right now it's not gonna make much sense. So Always watch for that where you have something and then the exact opposite. A lot of times you can do it by complement. All right, last one here. So from a class of 15 students, 12 students are chosen to have lunch with the president. How many different selections can there be? So how many students are there? Exactly, 15. And we're going to choose 12. So there's 450 ways, 455 ways we can do that. So imagine there are 15 people here. I could just go and you, and you, and you, and you, and you. And I could count 12. We're going to lunch with the president. Okay. Now, 3 choose. We're still a class of 15. 3 students are chosen to have lunch with the vice president. How many different ways you can do that? So this 15. Choose 3. Excuse me. Hey, look at that. Okay, so my point here is if you had to do it and you were picking the 12 students to have lunch for the president, could you see you could get the exact same process done if instead of picking 12, you just picked the 3 that didn't go? Okay, so 15 choose 3 is equal to 15 choose 12. So the sneaky part here is these 2 numbers. If they add up to the front number, they're going to be the same. So choosing 3 and choosing 12 are, they're not to complement each other, but you get the same answer. Because I always think of it, instead of choosing 12 students, I could just choose 3 that aren't going. If I have 25, choose 20, that could be the same as going 25, choose, if these are the 20 that, I don't know, are going to get to go on a trip, you could also turn around and choose the 5 that aren't going. These 2 numbers will always match up. And this becomes more important. So let's say 100, 98 is equal to, okay, look at our pattern. What number goes first? Right, 100 first, choose 2, 8 and 2. So if there's 100 books you have to read, no, there's 100 books. You have to read 98 of them. Oh, wouldn't it be a lot easier to just say, you know what, I'm not reading those 2. Same. Oh, those are always going to, oh, here's a tough one. One last one. What number is going to go in front? That's the other way to look at it. Got it? Exactly. These 2 numbers, if they're equal, are total up to that front number. All right, there's a little trick that I may or may not talk about in class, so you have some extra information. Cool.